Hi everyone, welcome to question and answer session with Rising Scholars. We are very excited to have you on board with us today, and we are recording this session that will be the recording will be further used on our socials to disseminate this program across various platforms so that other scholars will also benefit. A message must have popped up on your screen when we turn on the recording. So your being here indicates the consent to being recorded. Thank you so much. My name is Asta Subedi. I work as a community administrator as Rising Scholars along with my many colleagues. And we work to make sure that there is equitable research ecosystem throughout the Global South. And this is our first ever interactive question and answer session where you'll be asking questions on descriptive and inferential statistics rather than the use of typical lecture method. Will thrive on directly responding to your queries, whether you are struggling to understand p-values, confidence interval, or you are stuck somewhere in data analysis in your ongoing research work. And we have very accomplished researcher Felix with us today. I will briefly introduce him before handing it over to him. So, like I already mentioned, Felix Emeka is an accomplished researcher, analytics, and data science professional with demonstrated ability to develop and implement data-driven solutions in the urban and health sectors. With over 10 years of experiences in teaching, leading epidemiological, biostatistical, and data science projects, from descriptive to predictive analytics. He's also a trained research scientist, scientific writer, and epidemiologist in his day to day duties at the Center for Health and Development, CSD, a center that evolved from several years of international research collaboration between the University of Port Harcourt and the Dalalana School of Public Health at the University of Toronto, Canada, and most recently, the University of Ottawa, Canada. He is a convener of the Rising Scholars Data Science Hub in apps. Also, he advises on a potential curriculum for statistical data analysis online courses, and he is our beloved steward. Apart from that, I'd like to set some ground rules. Please raise your hand if you'd like to ask any questions. You can turn on your video throughout the session to make it more interactive. Please make sure you use the interactive features of the Zoom, including the closed caption feature that is available to you. If you click the More option in your toolbar, you'll find the closed caption feature that allows you to access this program in various languages. And anytime you have any problem, you can reach out to me via direct message, and I will try and solve the technical errors as they arrive. So now I'd like to hand it over to Felix. Over to you, Felix.
Okay, thank you, Asta, for that lovely introduction. I hope you can hear me. So yeah, so like we said, it's a Q&A session. So I would wait for the first answer. So it's you ask your questions, then I'm able to respond to you. So I see Dr. Zainab wants to be first. So yeah.
Definitely. Good morning, everybody. And I think I'm more excited to have Felix here than he probably is to be here. So my first question refers to one of the sessions you held with us some time back about deconstructing p-value. So for somebody who isn't a data scientist, just a researcher that needs a lot of help with research, I'm reading a paper. How can I spot a few of the common pitfalls where the author has hidden under p-values to present his results? What should I look out for? In other words, p-value 101 for the statistics illiterate. Thank you.
Okay. Yeah. So what I can say about the p-value, sometimes it's called the probability value, which is the full name. It's more like a value that we use as evidence. Let me put it this way. the moment you are doing a research and you have crafted a form of a hypothesis simply means you have an outcome you want to measure. Like for those of us in the health sector, that outcome may be like you want to measure preeclampsia, you want to measure tuberculosis, you want to measure malaria, and you want to see how certain independent variables, sometimes they are called determinants, how they influence preeclampsia or malaria or tuberculosis. For example, you may want to know whether certain places people live may make them more susceptible to having TB. So you may be asking them, where do they live, if they live in the rural or in the urban area? So that's the residence or the location. Now, crafting a hypothesis from that would be, that's the null hypothesis would be, there is no significant association between residence and tuberculosis, or between location and tuberculosis. Now you've crafted a hypothesis, and for you to be able to answer that hypothesis, you have to run an inferential statistics, meaning you have to run an association. Now, because residence is categorical in its form, meaning that they are rural or urban, that makes it categorical, meaning that it's describing it would be in frequency and percentage. Tuberculosis. So which means in measuring that hypothesis or the null hypothesis which you have crafted, which is there's no significant association between residence and tuberculosis, the test of significance you're probably going to be using in answering that hypothesis is the chi-square. The reason why you're using the chi-square is because you're checking for differences in percentages. Like I said, residence and tuberculosis, they are automatically by default categorical variable, meaning you're going to be measuring them in frequency and percentages. So because you're going to be checking for differences in percentages, meaning if those that are in rural area, do they have more TB? Yes. Or if those in the urban area, do they have more TB? Yes. So that's checking for differences in percentages. So you're going to be using the chi-square. Now, the chi-square is the test of significance. It has a value. That value can be 3, it can be 10, it can be 15, it can be 20. But the thing is that the chi-square doesn't have a range. So you cannot look at the chi-square value and be able to tell whether that association you have done is statistically significant or not, meaning whether living in a particular area makes you more susceptible to TB. You won't be able to tell just by looking at the chi-square. That's why anytime you run a statistical analysis, it gives you the test of significance, which in this case is the chi-square, but at the side of it, it will also give you a probability value, which is the p-value, because it is the p-value that gives you a clue what the chi-square is saying. So the p-value has a range by default, which is less than or equal to 0.05. So if you run that hypothesis, you run that association, and you have a chi-square like 24.5, and you have a p-value that is 0.01. So 0.01 is less than 0.05, which is the cutoff. So it means that that association you have done is statistically significant or not, which may be that those living in a rural area is statistically significantly higher in having a higher prevalence for tuberculosis. So in other words, the p-value is the evidence that tells you what the test of significance, which is the chi-square, is saying. So for a newbie that, it's looking at the chi-square, what I would recommend is have an idea, the cutoff, which is the 0.05, all right? And if the p-value is 0.00000, sometimes it can be 0 infinity, then you have to be abbreviating, but abbreviation means you have to put the first 2 zeros, meaning it has to be 0.00 then 5. Sorry, 0.00 then 1. All right, so that gives us a clue that it's infinity, or you can do less than 0.001. All right, now there are instances where people will do things like less than 0.01. Now, the moment you see less than 0.01, that is not correct, because 0.01 is not an infinity number. Infinity number is like 0.000. So for you to do a less than 0.0, it has to be 2 zeros at most, 0.001. Okay, and any value that is greater than 0.05 would not be statistically significant. I've seen an instance where people would put probability values that are like 0.28 or 0.25. All these values are higher than 0.05, and they tell you that it is statistically significant. Reason being that they read a paper and that paper said that their own cutoff was 0.28, and you decided to use 0.28 because of a paper you read. The thing is, the universally accepted cutoff is 0.05. So if you're going to be using any p-value that is not 0.05 as a cutoff, then you're going to be making a very strong justification on why you are using that p-value. And also, when using p-value, please, I always recommend, especially for early career researchers, to have the test of significance there. Sometimes I review papers and you're doing an association where you're testing differences in percentages. The test of significance is chi-square. The p-value is just the probability value, which is the evidence that tells you what the chi-square is saying. So proper practice is put your chi-square, which is the test of significance, and you can put your p-value in bracket. All right, but in a case where you would ignore your test of significance and only put the p-value, I do not recommend that. So have your test of significance for, and another example is if you're checking for differences in two means, all right, two independent means, of course, you know what it is. It would be the independent student t-test. So have that independent student t-test there, then in bracket, you can put the probability value. Don't just throw away your test of significance and only have your probability value. I usually do not recommend that because the probability value only gives you a clue what the test of significance is saying. If you're going to be accepting your null hypothesis or you're going to be rejecting your null hypothesis. So sometimes people would prefer to use the confidence interval instead of using the p-value. It is still fine. Now, how the confidence interval works is the moment you have the lower range and the higher range, all right, and there's no one in between the lower range and the higher range. For example, if you have 0.3 as the lower range for your confidence interval and the higher range is 0.8. Now, 0.3 and 0.8, there's no one in between that minimum and that maximum range. So the p-value will most likely be statistically significant. Anytime you have a confidence range where there's no one in between, like 0.3 and 0.9, there's no one between 0.3 and 0.9, like 1.38 and 3.33. There's no one between 1.38 and 3.33. The one was before the 1.38. So those ranges, the p-value will most likely be significant. But when you have ranges where you have one in between, like 0.3 and 1.39, there's one in between because after 0.3, you will get to 1 before you get to 1.39. So there's a 1 in between that range. So when there's a 1 between your minimum and maximum, you will most likely be having non-probability significance. So I think I would stop there. I hope I was able to answer your question, Dr. Zena. Yeah, thank you.
Very well. You did very well. Thank you.
A quick one from the chat box. Someone asked when to use the chi-square test. Like I've said, you use the chi-square test when you are checking for differences in percentages in your hypothesis you've crafted. As long as you're checking if one percentage is significantly higher than another percentage, then you're going to be using the chi-square test. Yes, it's used for checking differences in percentages. And another person is asking in the chat box, how does descriptive statistics differ from inferential statistics? Well, in descriptive statistics, you don't make any inferences. That's how it differs. In descriptive statistics, you just describe your data. Like in descriptive statistics, you can tell us what's the percentage of those that are between the ages 10 to 15 years, What's the percentage of those that are between the ages, 20 to 29 years, You can tell us the number of those that are males, the number of those that are females, the number of those that have hypertension, the number of those that don't have hypertension. That's descriptive statistics. You are basically describing the data. You're not making any form of inferences, okay? You describe the data the way it is. But when it comes to inferential statistics, it means you have first of all crafted a hypothesis, all right, where you're saying that there is no association between an independent variable and an outcome variable. Like the example I gave, I can give another example. There's no significant difference between a history or a family history of preeclampsia and actually having preeclampsia. All right, that's a null hypothesis. There's no significant difference between a family history of preeclampsia and actually having preeclampsia. So that's a null hypothesis. So the moment you have a hypothesis, then it becomes an inferential statistics, because once you have that data now for family history of hypertension, which will most likely be yes or no, then preeclampsia, which will most likely be yes and no, then you're going to be checking if those that have more family history of preeclampsia actually have more preeclampsia. So you're going to be checking the number of yes for family history of preeclampsia and the number of yes for preeclampsia. So if you're checking the differences of that percentage, then you're using the chi-square. But the moment you're having to check whether an independent variable influences an outcome variable, it's automatically an inferential statistics, because there you're making an inferences. If those that have more family history of preeclampsia would most likely have preeclampsia. So that's inferential statistics. So someone is asking, what statistical tool for discriminant measurement to determine prevalence? Okay, I'm not sure if I understand what discriminant mean, but if you're talking about a statistic tool, determining prevalence, it's like descriptive statistics. Prevalence is descriptive, it's not inferential. Because when you say prevalence, you have an exposed group, and you want to know the number of those that have the outcome you're interested in that exposed group. All right. For example, you have an exposed group that are exposed to loud noise or loud sound pressure level. And in that exposed group, you want to know how many of them will have noise-induced hearing loss. So the number of those that have noise-induced hearing loss inside that exposed group is your prevalence. So you would just be running descriptive statistics, meaning frequency and percentages. So that percentage is what gives you a prevalence. So you may not likely be doing any test of association in this case. Yeah. So John.
Okay, thank you very much. Good morning. I'm John from Ghana. I'm a beginner in research. This is very important for me, and I don't know how I could be mentored to grab, especially inferential analysis. If I could get a mentorship, or if there's a site I could download some of your recordings to learn more. Thank you.
Yeah, thank you, John. Yes, you can actually, I think some of my webinars, they are actually in Rising Scholar website. So you can even go to YouTube and type my name as well. I think I have some webinars there as well that I've done, where I start from scratch, how to be a data analyst and progress data strategy and the rest of them. So alternatively, I will just drop my email here quickly. So I have some kind of a list, all right, of that. Okay. We also have the Rising Scholars Data Science Hub. Yeah, I will not be able to share that now with you, but the Rising Scholars have a data science hub, meaning it's a platform where we deal with data analytics and data science and the rest of them. So yeah. Hopefully I would be able to share that with you. Yeah, okay. Yeah, but at the end of the webinar today, I think Asta will be able to share some links that you can join the Rising Scholar if you're not already a member. Okay, yeah, so she actually shared some. Yeah, exactly. Thank you, Asta, for that. So that is the link, for the hub, so you can actually join. Yeah, thank you, John.
Great, thank you very much.
Yeah, so Abib, before I take something in the chat box, let me hear from Abib.
Good morning. My name is Sabi from Nigeria. So my question is that concerning how are you going to know if the data is normally distributed or is not? That is my first question. The second is that concerning the parametric and non-parametric situation. So how are you going to know the type of parametric measure that you are going to put in place? So, and if the data is not normally distributed as well, so how are you going to know if the type of non-parametric that you are going to use as well? Thank you, sir.
Thank you, Abib. So this is the way it actually works. You know, when we are conducting research, researchers are usually recommended to use probability method of sampling. Yeah, probability method of sampling is where you follow a process, a systematic process, where you give every participant or every eligible participant in your population an opportunity of being selected. The most popular one is the simple random sampling, you know, where you have a sampling frame. Sampling frame is usually everyone that is eligible for that study, gives you the sampling frame, then you can use simple random sampling and pick the number you need based on the sample size you've calculated. There are others like the cluster sampling, we have the systematic sampling, you know, so all these, they are actually probability sampling. And if you're doing some very high level of research, like the randomized control trial, by default, you're going to be doing randomization. So meaning that you are going to be following a systematic process in selecting who is going to be joining your intervention group or who is going to be joining your control group. So you see these methods of selecting your sample systematically, you know, saves you from the issue of having your data skewed. So if you're able to select your data using this probability sampling, there's a good chance that your data will be normally distributed. Normally distributed simply means that you have a pattern that shows that every eligible participant had equal chance of being selected. All right. So if you follow that probability method of selecting your sample, you'll probably not be having a skewed data. Skewed data happens when you don't use a probability sampling. Like for example, convenience sampling. You just choose the people based on convenience. Let me give you a very quick example. I had some colleagues in medicine that were doing a study on weight circumference and how it relates to hypertension. And if you read literatures will always tell you that there is a high probability that waist circumference has a significant association with hypertension. But their studies was not showing anything in line with literatures. And trust me, they were not doing a novel study. They were simply doing what others have done, just replicating it in their own setting. So I was not expecting their study to be far from what literature is saying. But I mean, that is what the data is showing. So I had to ask them, how did they collect the data? And they said they collected the data from their colleagues, their classmates, and these are medicine students, and you know their age range, they will probably be between 30 years and below. Imagine doing a study on hypertension and you're collecting data from young people. Of course, the data is already skewed because you didn't give even the right population, which is those that are 50 years and above, of being selected. You just targeted your colleagues, your classmates. So that's an example of convenient sampling. And those kind of data are most likely skewed. And when you have all those kind of data, you follow what they call the non-probability method of statistics or analysis. So testing for normality, there's something they call the Shapiro-Wilk normality test. You can find that in SPSS, the Shapiro-Wilk normality test. So you go there and you check for the normality of your data. It will give you a value, but it will also give you a p-value. Now, if that p-value is less than 0.05, meaning that p-value is statistically significant, the interpretation is that your data significantly deviates from normality. As long as that p-value is significant, it means your data significantly deviates from normality. What that means is you're definitely going to be using non-parametric method of analysis. So how does parametric and non-parametric differ? Now, if your data is normally distributed, you're using parametric, meaning you're going to be focusing on the mean. So if you're doing an inferential statistics for the means, meaning you're checking for differences in two independent means, you're using the independent student t-test. If you're looking for differences in two paired means, meaning a pre-mean and a post-mean, then you're using the paired student t-test. So if you're checking for differences in three or more means, you're using the analysis of variance, which is also called the F statistics. So these are examples of parametric. However, if your data significantly deviates from normality, then you're going to switch to non-parametric, meaning your focus will now be median. So instead of checking two differences in two means using the t-test, you're going to be checking for differences in two medians, and you're going to be using the Mann-Whitney. Instead of checking for differences in three or more means using the ANOVA, you're now going to be checking for differences in three or more medians for non-parametric, and then you're going to be using the Kruskal-Wallis. So this is how the normality relates with what type of analysis you're going to be doing, whether it's parametric or non-parametric. So I hope that is clear. So before I take Dr. Zainab again, I see your hand. Someone asked in the chat, provenance is source of materials. Honestly, I'm not clear. Mary, if you can unmute yourself and ask, probably I'm not clear. Someone asked in ROCT, that's randomized controlled trial. Let me read that. In ROCT, if you have 3-point measurement and some level of attrition among respondents, okay, which statistics tool should be appropriate used to understand the difference between two treatment groups? Is it ANOVA, LAM, and Y? This is what I'm confronted at the moment with my study. Okay, so it depends on what you are measuring. So you are looking at differences between two treatment groups. What type of data are you collecting? All right, because you also have to understand your scale of measurement. Is it continuous data you're collecting? Is it numerical data you're collecting? Is it categorical data you're collecting? So the nature of data you're collecting, will depend on what test of significance or what, association that you will be doing. So if you collected continuous data, that's numbers. Continuous is different from discrete. Discrete are numeric numbers that don't have decimals, like whole numbers, like number of cars. You can have 1.5 cars, all right? Parity, number of children. You can have 1.5 kids. It's either you have one kid or two children. So things like parity, number of cars, number of houses, those are discrete because they don't have decimals. They are whole numbers. But there are some variables that have decimals. For example, weight would probably have decimals, BMI, height, even age, it's continuous. It's just that sometimes we treat age as if it's a discrete. Imagine asking someone, how old are you? And they say, oh, I'm 20 years old. Now, you can only be 20 years old if that day is your birthday. If that day is not your birthday, you're probably 20 years and 3 days, or 20 years and 1 month, or 20 years and 3 months. So age is actually a continuous variable, not discrete, you see. So if you collect continuous variable and you're dealing with 3 groups, like I said previously, and you want to check the difference in the means of these 2 groups, of course, you're going to be using independent student t-test. But if they are paired group, meaning you collected the means one time, then after another time, you collected another mean from the same population, then it's the paired student t-test. All right. So if it's 3 groups and you're collecting 3, checking for differences in 3 or more means, then it's the analysis of variance like you mentioned here, which is the ANOVA. But if it is ordinal, and you want to check the relationship in ordinal variables, you want to see whether if one, ordinal variable is increasing, is the other ordinal variable increasing or reducing? So this is ordinal. Ordinal, like Likert scale, agree or strongly agree, undecided, disagree and strongly disagree. This is an example of ordinal variable, like a Likert scale. Now, doing association for Likert scale, most times we look at flow, increasing ordinal or reducing ordinal. In that case, you're going to be using the Shapiro, the Spearman's, Spearman's rule, all right? But if you're checking the same flow in continuous, not ordinal now, then you're going to be using the Pearson's correlational coefficient. So Pearson's is for continuous, while Spearman's is for ordinal. But if you're switching to categorical, like I said, whether it's 2 groups, but you're checking differences in percentages, or it's 3 groups, or you're checking differences in percentages, then the chi-square will do the job. All right. But if I didn't answer your question well, then you can unmute and ask. So Dr. Zainab, you wanted to ask something again?
Yes, I just wanted to add to I don't remember, John from Ghana, that Astash will be posting a link to the Rising Scholars Mentorship platform. So that's where you can also submit a request for mentorship, and our community will respond to you. Thank you. That was all I wanted to add. Thank you.
All right, thank you, Dr. Zainab. Rumbizai, I hope I pronounced your name well.
Hello, how are you? This is Rumbizai Mendri from Zimbabwe. I have a question on the percentage level of significance. For example, let's say we are testing for the influence of socio-economic factors on technology adoption. On what level can I say age affect technology adoption at 5%, at 1%, or at 10%?
Okay, can you say that again, please?
All right. I was saying, asking about the level of percentage level of significance levels. For example, let's say I'm testing for the socio-economic factors on technology adoption. At what level can I say age affects technology adoption at 1%, at 5%, at 10%? Just want to understand on the P values again.
Okay, yeah. So the 1%, 5%, 10%. The way the P value is, you can say that just by looking at the number that is generated. If you have a generation of P equal to 0.01, I think 0.01, 0.01, I think that should be 10%, 0.01. Yeah, so 0.01, okay, 0.01 is 1%. So if you have a P that is 0.01, that is 1%. Then if you have a P that is 0.05, that is 5%. So it's more like timesing the P value that is generated with 100. So whatever P value that is generated, if you times it by 100, then you're going to be getting the percentage of the P value that you want. But it's just that in my own field, we don't usually classify these things in percentages per se. We just use a cutoff. That's for public health and epidemiology. We just use a cutoff. And as long as that P is less than 5%, which is the less than 0.05, then we say the 2 variables we are measuring, meaning the independent variable, as you had mentioned now, and the outcome variable, they have a difference in terms of their proportion or their percentages. That's if you're checking for differences in percentages. But with respect to the 1%, 5%, I think if you times that P value number, the probability number with 100, it will be able to give you the percentage. I hope that is clear.
Yeah, that is clear. Thank you so much.
All right, thank you. Before I take another hand, there's a chat message. It says, Noye from Nigeria, please, can you explain to us the situation to use other inferential statistics, example, ANOVA, t-test, z-test? Most works have always used only chi-square. Yeah, so you've almost used only chi-square. I think I've actually explained this. You've only used chi-square, and not like you're only using chi-square, but chi-square is because of what you're measuring. So the reason why you were using chi-square is because you were checking for differences in percentages. That's why you were using the chi-square. Okay. So if you're checking for differences in 3 or more means, you'll be using the ANOVA. For 2 means, you'll be using the t-test. So I think I have a whole blog, where I talked about I talked about test of significance. I think it is on the Rising Scholars. It's on just give me a second. It's on the Rising Scholars website. I have a webinar. No, sorry, not a webinar. A blog where I spent part 1 and part 2. It was a really big blog talking about test of significance. I think it will be very helpful to you. Just a second. I'm trying to, yeah, I have seen it. So I'm going to post it here. So you can go to the blog. I think it will be very, very helpful. Sorry, just a second.
I can send it, Felix.
Okay, yeah. So there's a blog, statistical significance level, part 1 and
I
part
found
2.
it.
Okay, good. Thank you. Yeah, thank you, Esther. So that is very, very helpful. Okay, so I think I have answered that. So let me see if I have another question in the chat box. Can you throw some light on how to analyze CAP studies? Yeah, so Jeremiah, when you say CAP studies, I guess you mean knowledge, attitude, and practice, right? So that I'm clear we are on the same picture. Jeremiah? Yeah, Jeremiah. Okay, why wait for Jeremiah? I want to be sure that CAP is talking about is knowledge.
Hello.
Attitude. Yeah, is this Jeremiah?
Hello. Yes, this is Jeremiah.
So when you say CAP,
I'm actually referring to knowledge, attitudes, and practices study, like you mentioned.
Okay, fantastic. So knowledge, attitude, and practice. First of all, if you're doing descriptive for knowledge, attitudes, and practice, of course, you will just describe the knowledge, describe the attitude, describe the practice. All right, meaning the knowledge score, the attitude score, and the practice score. However, this is not as straightforward as it is. Reason being that you don't ask people, do you have knowledge? Or do you have attitude? Or do you have practice? If not, it would have been very easy. Asking someone, do you have knowledge? If the person says yes, you say, oh, you have knowledge. If the person says no, then you say you don't have knowledge. Then it's easy to just measure. But when it comes to knowledge, attitudes, and practice, you usually create some questions, all right? We usually recommend students to create at least 10 questions each, because for you to measure knowledge, you need at least minimum 10 questions to measure knowledge. So you are going to be asking, depending on what you're getting their knowledge for, is it on HIV/AIDS, whatever it is, then you're going to be putting there 10 questions, asking them 10 questions. Now, those 10 questions, you're going to be scoring it. Probably you are going to be putting those questions as a Likert scale: strongly agree, undecided, strong disagree, or strongly disagree, fine. Or you're going to be using yes, no, I don't know. It depends on what scale that you want to use, but you're going to be asking them 10 questions to measure knowledge. Then depending on their response, correct answers usually is scored 1, wrong answers are usually scored 0. So if the person has answered among the 10 questions, the person has gotten 6. So it means the person got 6/10. Then you're going to be doing the scaling. What is your cutoff for good knowledge and what is your cutoff for poor knowledge? It depends on what cutoff you want to use. You can use 50% cutoff. If they got 5 answers and below, it means when I grade, they have poor knowledge. If they got 6 answers correctly and above, it means they have good knowledge. It depends on your cutoff. The one thing I can say about knowledge before I go to attitude is there are certain questions that are actually not knowledge. We think they are knowledge, but they're actually awareness. All right? Imagine asking someone, have you heard of hepatitis before? Or have you heard of HIV/AIDS before? I mean, that's not a knowledge question. That's an awareness. Now, when you want to ask a knowledge question about HIV, you're going to be asking things like, do you know if a mother that is HIV positive, that is breastfeeding, can transmit the virus to the baby? That's a knowledge question. They're simply asking the person, have you heard of HIV/AIDS or not? That's simply awareness. So sometimes you see people craft knowledge questions and they're actually asking awareness and not really knowledge. Knowledge questions are questions that you probably have to read somewhere, not something you just heard without having any form of brain stimulation. So for the attitude, you do the same thing. So you're going to be asking them series of questions and you're going to be scoring it. At the end of the day, they are going to be having good attitude or poor attitude. The same thing with practice. You're going to be asking them series of questions and you're going to be scoring it. And at the end of the day, you're going to be having good practice or poor practice. Now, when it comes to the association, apart from the descriptive, which you're going to describe how many has good knowledge, poor knowledge, how many has poor attitude, good attitude, how many has good practice, poor practice, that's simply the descriptive. You are also going to be doing some inferential, because the reason why you're doing knowledge, attitude, and practice is because you want to see how knowledge influences practice and how attitude influences practice, or how knowledge influences attitude. So that's inferential. So you're going to be doing an association between knowledge and practice to see whether a higher percentage of those that have good knowledge have better practice. So knowledge, remember, it's a categorical variable now because you've categorized it into good and poor. Practice is also categorical because you've categorized it into good and poor. So it means you're going to be checking for differences in percentages. The number of good that has good practice, the number of good knowledge that has good practice, and the number of poor knowledge that has good practice. That's percentage. So automatically you're going to be using chi-square as the test of significance. All right. But if you're using a Likert scale and you want to score it, if you're going to be scoring it and you're going to be having a cutoff score, then if you're checking for differences in the score, if it's a median score, in this case, because it's a Likert scale, you're probably going to be checking for differences in medians, not means, because it's Likert. So it's going to be a discrete variable. So if you're checking for differences in two means, because you have scored the Likert scale between the median for the knowledge and the median for the practice, then you are going to be using the non-parametric, which is the Mann-Whitney, so it depends on what you want to do. I hope that is clear. So Peniha for Johannes, you can ask your questions now.
Yes, so thank you for the platform. I'm Peniha from Namibia. My question is not tough. I just wanted to ask, I'm an epidemiologist resident, currently doing a descriptive study. So I've collected data which I want to create forms on using EpiInfo. However, it's my first time. So I just wanted to ask if I can create forms, enter the data, and get a line list which I can use to at least analyze the data in Excel.
Okay, so because moving from EpiInfo to Excel, I would not recommend that pattern. And honestly, I would not recommend you doing your data entry in EpiInfo. You know why? At least I have been using EpiInfo for almost like since 2000. That's like 25 years, So I can tell you for sure that it's not a good idea doing data entry in EpiInfo. You know why? Because for you to do data cleaning in EpiInfo, you have to enter that data twice. I don't think that is what you want to do, So it is a good practice to enter your data in Excel, because data cleaning in Excel is very, very easy. All right. Then after you clean up your data, you can now import it in EpiInfo and begin to run your data analysis. So I will recommend use Excel to enter the data, because EpiInfo gives you an opportunity to improve your Excel sheet. So you don't have to do because you would notice that EpiInfo behaves like a database. And because it behaves like a database, most times you don't easily have access to that data you've entered, unless now they have put a command where you can export your entry into Excel. So if you can export your entry into Excel, why not just do the data entry in Excel? So I feel the data entry in Excel, then importing it to EpiInfo and analyzing your data, it's better, so that you can still do data cleaning in Excel. which is a key aspect of your data analysis process.
Oh, thank you, sir.
Yeah, thank you too. So yeah, and I also want to add, for those that want to use EpiInfo is free. EpiInfo is actually the epidemiological software that was made for those, especially those in public health and epidemiology. So if you know how to use SPSS, you know how to use Arrow, you know how to use Stata, you don't know how to use EpiInfo, I think you have to think again, because if you're going for a United Nations interview, especially WHO and the rest of them, like CDC, they will be asking you if you know how to use EpiInfo, because EpiInfo is actually their own software, not XPSS and the many others. All right. So the Jeremiah, there's one of the thing he said that I missed. He asked if the CAP study require normality tests. Normality test depends on how you collected your data. So if you collected your data using probability sampling, like I said, you may not have issues with normality, but you can still check. I think every data, you can run them through normality tests, okay? But normality test is only run on continuous variable. You can't run normality tests on knowledge. You can't run normality tests on attitude. You can't run normality tests on practice. So you would look for a continuous variable in that your data, like the age. So you can run normality tests on the age. So normality test runs on continuous variable, not categorical variable. All right. So I'm scrolling. Penehafo, you have another question? Your hand is still up.
I know. I just have to put it down.
Okay. All right. So someone asks, if you say non-parametric tests are for skewed data, does it mean that all the chi-square used in most studies we see are all for skewed data? No. Chi-square has nothing to do with skewed data. Chi-square is a test of significance that is used for measuring differences in percentages. So chi-square has nothing to do with skewed or unskewed. The only thing that is influenced by skewed or unskewed is mean and median. So if your data is skewed, you are going to be using median. If your data is normally distributed, you're going to be using mean. And I've also mentioned the test that you're supposed to use if your data is skewed and if your data is normally distributed. So it has nothing to do with chi-square. Chi-square, it's only measuring differences in percentages. So I'm trying to scroll on the chat, so pardon me. I have another question from Noye. Is it the difference in percentages or the data normality that determines whether to use chi-square or not? Like I said, chi-square has nothing to do with normality. Normality focuses more on continuous variable. That's why when you're running Shapiro-Wilk normality tests, you are not going to be using categorical variable to check it. You're going to be using continuous variable like age, birth weight, height, BMI. Those continuous variable is what you use to check for normality. That's why normality influences continuous variable, not categorical variable, okay? So chi-square, it's on its own. You use chi-square, whether the data is normally distributed or not normally distributed, chi-square will work in both of them because you're using chi-square to check for differences in percentages, okay? So it has nothing to do with normality of the data. Anthony is asking, please, can one conduct inferential statistics without forming hypothesis? No, because it's the hypothesis that guides the inferential statistics. How would you want to run an inferential statistics when you don't have a hypothesis? Hypothesis, you want to see how the independent variable influences the outcome variable. Like I mentioned, independent variable can be, for example, exposure to loud noise, to loud sound, and the problem that would cause would be the noise-induced hearing loss. So your hypothesis would be there's no significant association between exposure to loud noise and noise-induced hearing loss, which is the problem or the outcome. So I've crafted my null hypothesis. Then I will now go ahead to do my inferential statistics to check whether there's truly a difference between exposure and outcome using chi-square if it's a percentage. So there's no way you can so you frame your hypothesis. Your hypothesis guides the inferential statistics. Yeah, I think the recording will be shared. Someone asked, I'm part of a global health research group and have therefore many data sets at hand, both longitudinal and cross-sectional, okay? Both qualitative and quantitative. It feels like I should go from descriptive to inferential statistics to start making sense of the data and explore hypotheses to the foundation for researching causal relationship between variables. Yeah. Is this a good approach, and how would I go from descriptive to inferential to explore cause and effect relationship between variables? Yeah, so like I said, descriptive statistics is like the first stage of the analysis where you describe your data. For categorical data, you describe them in frequencies and percentages. For continuous data, you describe them in means and standard deviation. For ordinal data, you describe them in median and interquartile range. So descriptive statistics is the first stage where you just describe the data depending on the scale of measurement, all right? But inferential statistics is when you now begin to check for inferences if one variable influences the outcome, because you have to appreciate the fact that for you to decide that you want to do a research, you're testing a problem. You want to check a problem. That's why you're originally doing that research, all right? But you also want to check if there are certain things that may make the participant more susceptible to that problem. For example, you find out in an environment that they have a higher rate of lung cancer, all right? So higher rate of lung cancer, you may want to pry and begin to see whether the smoking rate in that environment is high, or if they smoke, or if there is an industry in that area that is generating some toxic gas that is making them, have, lung cancer. So the lung cancer is the problem. That's what is motivating the research. But you're not going to stop there. You're going to be checking determinants of that lung cancer. So the determinants of that lung cancer, those are your independent variables. So that is what you would be testing with the problem. So that's where the cause and effect relationship comes. So you would definitely do an association, definitely, as long as you want to know the determinants of that problem, the things that are making them have that problem, you would definitely be doing an association. So Mary?
Thank you, sir. My question is, how can one do standardization of values? If I want to do the standardization of my values, how can one do it?
So the thing now is you can weight your data. So when you say standardization of your values, so first, what do you want to standardize?
Like I have some geochemical results, some elemental results, like maybe having, I don't know if you're a scientist, like maybe iron, aluminum is also maybe 97%, hydrogen is 19%, something like that. So I want to do the standardization of the values. So I don't know how to do it.
When you say standardization now, in your own case, which is the chemical, what do you want to achieve by the standardization?
Like I want to I was
So
one that asked the question on provenance, on discriminant. I want to determine, the source of material. For example, I'm in archaeology, so they have made this the geological material to make to manufacture tools in the prehistoric period. So I now want to determine where they have used this, they have extracted the material. Maybe it's very close or far from where we have the material. So that is what I mean by that provenance that I asked on the chart. Source of material.
Okay.
So I need a discriminant, tools that can be used to perform discriminant analysis. Statistical tools. Are you understanding?
I understand you, but probably because it's not my field.
I know. Yeah.
So discriminant. Yeah. So the only thing I can say, sometimes these things may be similar in terms of your own field and my own field. Yeah. So I may not be able to tell you in terms of the discriminant analysis, but I may be able to tell you what you would be getting out, depending on what you want to analyze. Yeah, so yeah, I'm not sure unless
it's only when I can understand you. It's somebody that is in science that can really.
in the chemical, I'm not so familiar.
Okay, sir. Okay, thank you, sir.
But I know there is a place where we come together. Yeah, there's a place where we come together, like in terms of you have the continuous variable now, and you can do something like linear regression,
Okay.
trying to see if one of the chemicals percentages is increasing, is the
Okay.
percentage of the other chemical increasing?
Okay, linear regression. Okay.
So linear regression, yes, that will happen. I know
Okay.
sometimes too for your own field, you do prediction as well.
What?
Prediction.
Prediction. Okay, prediction.
Yes, checking the percent at what percentage in one of the chemicals.
Okay.
That the other chemicals will also change, meaning an increase in 1% of this chemical. How many percent increase does it cause in the other chemical?
Okay.
Is it percent or so, but I may not be able to.
No, you've thrown light like this linear regression. I think if I'm able to go for, so I can do it in the, is it in Excel? Can I use Excel for it?
No, can use
Hello?
Yeah,
Hello,
no.
I mean, can I use Excel for this linear regression or prediction?
Yeah, so you can use Excel only if your Excel has a statistical add-on. You can't use the normal Excel.
Okay.
You have to get or download they call it statistical add-on. So you add-on.
Add-on, okay. Excel statistical.
Or Excel data analysis add-on.
Okay.
So you have to add that in your Excel. That's when you can use the Excel for data analytics process.
Okay.
You can use other statistical softwares like SPSS and the rest of them. Yeah. So but I am happy to work with you through the process. Yeah. So I think statistics or data analysis is general. The principles are usually general, but I know different units it can differ a little bit, but it will still work on the same principle.
Okay.
Yeah.
Thank you, sir. At least you did. I know it's not your feet. That's why, because I've been reading about you. So that's why you are not able, but at least you've thrown light. At least I can work with this at least. Thank you, sir.
All right. Yeah. Thank you. I dropped my email earlier, so if you can find it, yeah, I'm happy to work with you through the process. Okay. So someone asked, Annie, is there a standard or approximate number of questions you can ask responded considering issues of fatigue, quality of response? Annie, these things are not cast in stones, really. There's no standard number of questions, but what I would recommend is for every research you want to do, especially research that are looking at issues like fatigue, quality of life, those things usually have validated tools, so before you begin to draft your own questions and your own questionnaire, please check WHO or any of the health, just go to Google and type validated tool for measuring, or you can type WHO validated tool for measuring fatigue, or WHO validated tool for measuring quality of life or quality of something. WHO has most of these tools that are already validated, which you can use for your work instead of crafting your own questions, all right? Because if you craft your own questions, you're still going to validate it, all right? It's still going to go through the process of validation and reliability. Yeah, but if you're going to be using the WHO tool, you may not need to, go through that process of tool validity and the rest of them. But for the standard number of questions, I would not be able to tell you, but it is good not to have so many questions, because you know that the people that will be answering those questions, sometimes they may get tired when those questions are too much. So it's usually a good practice to at least get enough questions that addresses all your objectives. So if you have 5 objectives for your work, at least make like 7 questions for each of the objective, you know, so, or 6 questions for each of the objective. I think that should be fine, and ensure that the questions you have are adequate to answer those objectives. Please don't take your questionnaires to the field if you're not sure that all the questions you have there have the capacity to address your study objective, because if you go to the field with a questionnaire that is not able to address all your study objective, it means you're going to do that data collection again. All right, because I doubt that your supervisor will want to throw out an objective because you're not able to extract that data from the field. So that's really a good practice, okay? Ensuring that your questions can address each objective you have. So what I advise my students, so that they don't miss anything, let each section in your questionnaire address your objective. You know, section A in your questionnaire by default is the social demographic characteristics. Oftentimes, it's not an objective, it's by default. Every questionnaire should have social demographic characteristics where you measure the age, the educational level, the marital status, and all that. Because most of the disease condition or most of the things we are measuring, especially for those of us in public health and epidemiology, they have demographic impact, you know, so it's a good practice. Then your section B can be your first objective, specific objective. Your section C can be your second specific objective. Your section D can be your third, you know, so that at the end of the day, you're sure that in each of the section of your questionnaire, you have satisfactorily captured your specific objective. So that's a good practice. All right. Yeah. Jeremiah.
Yes, sir. I want to ask a personal question. I'm conducting a research on iodized salt, where my first objective is to assess the availability, accessibility, usage, and affordability of the iodized salt in a particular district. Then my second objective is to test the iodine concentration in the salt that is used at the household levels. Then compare it to the standard set by the WHO. Now, apart from the descriptive statistics that I'm likely to do, I want to know what are some of the inferential statistics I am likely to employ in my study.
Inferential statistics is based on your independent variable and your outcome variable. So I would ask you, what is your outcome variable? What is motivating you to do this research?
Hello?
Yeah, so like I said, the inferential statistics is based on your independent variables and your outcome variable. So for this research now, there's a problem you want to solve, which is the outcome. Yes. So what is that problem that you want to solve? What is motivating you to do the research?
The bigger problem is iodine deficiency within the communities, especially among pregnant and lactating women.
Okay. So looking at iodine deficiency. So that iodine deficiency now, are you going to be categorizing it into yes and no? Iodine deficiency, yes and no, based on a cutoff?
No.
So how are you measuring iodine deficiency?
This is actually an object. This is actually part of the study, an objective. The iodine deficiency aspect of the study is there, where I will take their urine samples to test in the laboratory for the concentration of for iodine levels in their system. Yes, but the issue is that one of the things that can solve iodine deficiency has to do with the consumption of iodized salt. There are two major determinants: the consumption of iodized salts and the consumption of food that contain iodine. So from literature, a community that actually relies on consumption of iodized salts will definitely be free from iodine deficiency. So I needed to start from that.
All that part is clear. So I am asking you, the researcher, how are you going to measure the deficiency? Are you using a number cutoff?
The deficiency of the iodine.
Yes. How are you going to tell somebody has iodine deficiency?
Okay, there are cutoffs.
Thank you.
There are cutoffs, yes. There are ranges.
Thank you. So those cutoffs are numbers, right?
Yes, sir.
So we are still saying the same thing. So for every test you do, you have a cutoff. So you
Yes,
are
sir.
able to push some people to iodine deficiency, yes, based on that
Yes.
cutoff. And you're going to push some people to iodine deficiency, no, based on that cutoff.
Yes, sir.
So you have two groups, iodine deficiency, no iodine deficiency. Then the inferential statistics now you are going to be doing is all those things that you think it's supposed to make them more susceptible to iodine deficiency. You're going to be associating all of them with iodine deficiency.
Okay.
For example, whether they take salt with iodine or not. So salt with iodine, yes. Salt with iodine, no. You're going to be testing if that is associated with iodine deficiency, yes or no.
Okay.
So if you're using percentages, you're going to be using the chi-square. But if you now want to use numbers, meaning the mean, but that will not be appropriate because for you to do deficiency, you would need a cutoff. And you're going to be categorizing people to deficiency yes and deficiency no. So the inferential statistics you are going to be doing is you're going to be associating all the things you think is supposed to make them have the iodine deficiency with iodine deficiency.
Okay.
So the iodine deficiency is your outcome variable. That one will not change. Then you're going to be checking other things with whether they have iodine deficiency, yes, or iodine deficiency, no. So if you're going to be doing association in percentages, then of course, you know, chi-square is your guy. But if you're going to be doing any form, which is the numbers now, then you know what to use, whether it's the t-test or the Mann-Whitney.
Okay. Thank you so much.
All right, thank you. So let me see. Someone asks, Matthias, which will you recommend, descriptive or inferential, for a study that seeks to combine with qualitative, that's mixed method? Okay. So the thing is that qualitative study does not have descriptive and inferential because qualitative studies don't measure numbers. Qualitative study only measures themes, themes, you know, like I don't know how to describe it. Like in my own study now, where I'm looking at strategies that will influence the use of HIV self-testing. So I'm asking the participants several questions, and they are telling me that cost is one of them. Most of them said cost. If the cost is lower,
Felix.
Yeah.
No, just a clarification on that. What I'm actually seeking to find out is not the qualitative bit, but I'm saying that you have the quantitative data and you are analyzing with the view to combining with some qualitative data on the same subject matter.
Yeah, so there's no combining here, which is what I'm trying to explain. There's no way you can combine quantitative and qualitative data unless the qualitative data you're talking about is not the one you collect using interviews and analyzing using in vivo for thematic. But if it's a kind of qualitative data where you're going to be counting numbers, then yes, you can combine. All right. So, but if it's a true qualitative study where you interview people, transcribe it, and bring out the themes, what we usually do is what they call triangulation. At the end of the day, you do some triangulation where you begin to combine where the quantitative aspect merges or improves on the qualitative, or where the qualitative improves on the quantitative. Yeah, but in terms of descriptive and inferential, you can only do that with quantitative data that you're collecting numbers or you're collecting categorical variables. So the descriptive is always the first step. You just describe the data. The inferential only comes in when you have a hypothesis, which is guiding your analysis. The hypothesis is you want to see how the independent variables influences the problem that you want to solve, which is the dependent variable. So I don't know. So unless you can tell me what type of qualitative data are you talking about? Is it the true qualitative, where you interview people, transcribe it, and use in vivo to analyze thematic? Or is those qualitative data that you put inside a questionnaire that you can still count? Because they are open-ended, you call them qualitative, not like they are true qualitative data. So let me hear from you, Matthias. Which qualitative data are we talking about?
Yeah, so thank you very much. I think I must commend you. I'm not just with this answer, but all along through the discussion, I have been getting some information that seems to be shaping up what I'm thinking about. But specifically, it's like I'm doing, let's say, study, in which case we are trying to examine, say, let's look at the knowledge of health workers on lifestyle diseases. And we now want to see the lifestyle practices, or whether these people, I mean, again, you made something similar when you talk about the KAP. So whether the knowledge of health workers really translates into real practical changes, which can serve as a role model for their clients. So if we say that, okay, you are supposed to eat a healthy diet, do you have knowledge of that? I mean, as a health worker. So you interview, I mean, using questionnaires, that one, we are using a questionnaire to find out a large pool of health workers, their knowledge of what is recommended as a healthy lifestyle if you are a diabetic or hypertensive. Now, you now want to look into their individual, just taking a sample of that and looking into their lives. Are they really living that proposed or suggested lifestyle, which they may know or not have known? That is a kind of, so in one bit, you do the questionnaire with a larger sample size, then you do interviews, which you now say the proper qualitative interview.
Okay, so very good. So if you had collected these two data using a questionnaire, you probably would have been doing inferential statistics. So meaning that based on the first quantitative data they have given you, you have also used quantitatively to measure knowledge or whatever you're measuring. Then you can do inferential statistics to see whether those individual questions will translate to their knowledge based on the quantitative question they've given you. But in this case, you're not doing it that way. You're using quantitative to collect one data, you're now using qualitative to collect another. The only way you can merge both, because you can't tell that the person that filled the questionnaire and said this is the same person that is giving you this response in the qualitative. You see where it's tricky. So the only way you can write this result is what I mentioned before, triangulation. So you can read more about it to see how it's done. Triangulation is used when you have two different types of data you collected from the same people, but you didn't track who is answering what. You didn't say the person that filled this questionnaire is the person that is giving me this qualitative response. So there's no way you can do using statistical software to do any form of inferential statistics, you see. But you can do triangulation based on the outcome from the quantitative and based on the outcome from the qualitative. You can find a way to merge. So if the practice is if the knowledge shows better quantitatively, and from your qualitative result, you can see that from their response, it shows that they are actually practicing well. Then you can infer triangulatively that the knowledge is what is responsible for their lifestyle or their practice. Yeah. So Matthias, I don't know if I'm able to answer your question. So the descriptive and inferential will only work for the quantitative. Yeah, but for the qualitative, you're going to be using a triangulation method. You can actually read about it and see how that is done. Since the two datas are not represented in the same tool, so you may not be able to do like direct association using inferential statistics.
That's right.
Yeah.
Okay. Thank
you. No worries. So someone asks, Revocatus, can't XPSS assist to see what is wrong during data cleaning? Yes, you can do data cleaning in SPSS. Yes, you can, but it's not very easy to do. I think I prefer data cleaning in Excel. Data cleaning is faster to do in Excel because of the sort and filter. Sort and filter is also in SPSS, but it's more rigorous compared to SPSS. I think for me, flexibility, since you can import Excel in SPSS, I think it's better. Just do your data cleaning in Excel, then import it to SPSS or any other statistical software that you want to use than going through the data cleaning process in SPSS. Yeah, so someone is asking how to address CMV bias. CMV. What is that? CMV, what is that? Is that common method variance, common method? So how was this data collected? So when you say CMV bias, Dr. Mansour, so how was the data collected and you think that you're going to be having or experiencing the common method variance, if that is what it stands for, bias? So I will be able to help you that way if I know how the data for the CMV was collected. Why we wait for you? Please explain the difference between correlation and regression. Okay, so let me explain that, then I can wait for the CMV. So the correlation for us in statistics, because sometimes when people want to use the word association, you want to see how one independent variable is associated with the outcome variable. Sometimes they will use that word correlation, but we don't usually agree with that. When we use the word correlation, our focus is on Pearson's correlational coefficient. So meaning that you want to check association of two continuous variables. For example, age is a continuous variable, weight is a continuous variable. You want to see if the person's age is increasing, is their weight also increasing? Or if the person's age is increasing, it's a continuous variable. Let's assume now you had measured quality of life using continuous variable. You score based on the quality of life. So if the quality of life continues, for example, you can use Pearson's correlational coefficient to see if the person's age is increasing, is the quality of life score also increasing? But if that score is ordinal, then you're going to be using Spearman's, which is also a correlation as well. But Spearman's is for ordinal. So we only use that term correlation. It means association, but we only use it when we are checking a pattern in two continuous variables, and when you're using the Pearson's correlational coefficient or you're using Spearman's. But the aspect of the regression, all right, there are several forms of regression. You can have linear regression. You can also have regressions that are not linear. For example, bivariant logistic regression. That is a form of regression analysis that is dealing with categorical variable. All right. So bivariant logistic regression deals with categorical variable. It's a regression. Multivariant logistic regression deals with confounding, analysis, which deals with categorical. But when you now want to do association between continuous variable, you can use linear regression. So the point I'm making is correlation only deals with continuous variables. continuous using Pearson's correlational coefficient or Spearman's. But regression can be continuous or categorical. Continuous when you are doing linear regression, but categorical when you're doing bivariate logistic regression or multivariate logistic regression. So I hope that is clear. So if it is about regression analysis, I advise Mary to go for SPSS. Yes, SPSS can do regression analysis very well. So Mary, if it's regression analysis you want to do, that's like the bivariant, the multivariant, or the linear, I think EPINFO can do linear regression. EPINFO can do linear regression, but EPINFO is not very good with doing bivariant logistic regression and multivariate logistic regression. So if you're doing linear regression, yes, you can do it in EPINFO. But if you want to do bivariate logistic regression or multivariate logistic regression, I would advise you use SPSS. So, okay, mixed method. So someone is talking about the mixed method. Yeah. So mixed method is when you use the quantitative and the qualitative method together. So a mixed method combines, yeah. So, but the data with numbers are only used for inferential exactly during the analysis stage. Yeah. Why qualitative ones uses thematic analysis exactly or content analysis exactly. Yeah, so thank you, Revocatus, for that. Yeah, same thing I was trying to explain. Someone is asking, Noye is asking, can you throw light on? We need to.
Yeah.
So Noye is asking, please, can you throw light on direct standardization and indirect standardization in comparing example age of two population in different age comparison? So in a practical way now, I don't know how. Let me try to explain that in a simple way that you are going to appreciate it. So when you say direct standardization, all right, it is age specific. Okay, direct standardization is age specific from your population, all right, which is the common standard, all right. So for example, you have age group 0 to 14. You have like the population A, which has a rate. You have population B, which has a rate. Then you have the standard population. So if you're doing standardization, then you're going to be multiplying each age specific rate times the standard population for that age group. So so the thing is, these things are really not things I can explain verbally and you would get it, because they are more calculation based. So for example, you have a population A, all right, and that population A has 1,000, and you have a standard population which is 10,000. So the standardization would be the population rate times the standard population. So it gives you a rate which can be 5.33 by 1,000. It's not explaining calculations verbally, it's not, but what I can say is the direct standardization, it is age specific rates. Then the indirect one, you apply a rate from a reference population, from a reference population. So so I think for Noye, if you can send me an email, I'll be able to share some materials that are easy, to compare both, but it's not something I can explain verbally, no matter how you may not be able to appreciate it, unless I'm showing you the calculations and how it is being done. Analysis of clustered data. So Sadia, so when you say clustered data, so what do you mean by clustered data? So let me hear from you. So Sadia, what do you mean by clustered data? So that I'm sure we are on the same group, because clustered data can be a cluster, the same population, like the same patients in a hospital, the same students in a school, the same employees in a company. That can be clustered data. So, but for you, when you say clustered data, let me appreciate what you're trying to say. Hello? Okay. Thanks so much for your time. Please explain types of inferential statistics and how to use it. So I think inferential statistics and how to use it is well explained in the blog. Yemisi, I think there's a blog that Asta shared. It will throw a lot of light on inferential statistics. So I think I had said a lot about it. So Asta, if you can post that again, if you still have it, the inferential statistics blog that I wrote, the part 1 and the part 2. So Yemisi, or Yemisi, yeah. So look out for that, please. Okay, I think I have addressed all the questions in the blog, in the chat. So, but if I didn't answer your question, can you unmute yourself and ask? We still have a few minutes before we go. So, Jeremiah, your hand is still up. I don't know if you want to ask something. Okay, Emile, please ask your question. Emile?
Hello, sir. Thank you. Thank you for sharing this best presentation. I'm Mr. Min. I join you from GLC, from Congo Kinshasa. I know many persons, or also my country. We are here, French country, but last time I tried to be bilingual. That's the reason why I can speak in English. So don't care about my pronunciation and others words. I'm a French speaker. So for this session, I like to give my point of view according to the topic in English, because it is an international language. So, Jen, very late session. I thank you again for this wonderful topic that you are debating, and this insight, that input that can help us to enhance our skills in analyzing for inferential statistics. So I find some comments here when someone tell us that inferential statistics can be used the only way in mixed method if they are qualitative and quantitative data, and inferential statistics is just needed for quantitative data where there is a number for making inferential. So I like to know, with this square, I think even if we haven't the numbers or quantitative data, with qualitative data we can just measure some relationship or correlation between some variables. I don't know if I'm wrong. So if it was in French, I would like to explain it in depth, so you can listen me. I have some difficulty to explain that what I'm feeling now. So the T square help us to measure, to make inferential statistics for qualitative data. If we like to know the correlation between some variables, I use it for my My memories, I don't know what we call that in English. When I finish my master, we have a work that we call dissertation or thesis, something like that. But I know this is for PhD position. But in master, I worked with chi-square to determine the relationship between some variable in adolescent age, what can lead some adolescent or teenagers to have pregnant, not desire. So we use it inferential static with chi-square. So I like to presentator to panelists to help us understand well if we have just qualitative data. So inferential statistics is not permitted, is not needed, or they have another way to make inferential statistics. Thank you.
Yeah, so thank you, Emily. So I think I kind of grabbed most of the things you were saying. So I think the first thing I grabbed, yeah, you were trying to distinguish between the quantitative and the qualitative. Yeah, so which you distinguished correctly. The quantitative, we are dealing with quantity of the data. So because we are dealing with quantity of the data, like you stated, yes, we can do inferential statistics. We can do an association between one of the independent variable and the outcome variable. Yeah. And you also said in your own association, I think you used like the chi-square. I hope that is what I heard. The chi-square or the q-square, which I think is still the chi-square. Yeah. So it's probably because you are associating an independent and an outcome variable, and there's a percentage in between that association. Like I said from the beginning, as long as you are checking for differences in percentages, then you're going to be using the chi-square. But I don't know if you meant q-square, although I'm not sure if I know about q-square, but I am assuming you meant the chi-square. So for the qualitative, yes, you had said correctly. Yeah, when it comes to the qualitative, there are some posts here, people recommending like Farah and also Ali, they are recommended in vivo and also MaxX, which are also softwares that you can use for qualitative. So what they do is they analyze themes, not quantity. So qualitative analysis will not be able to tell you 10% of people did this or 20% of people did this. No, it will just tell you what they thought about and what they said exactly. I mean, what quote, like it can tell you that most of the participants were in agreement that if the cost of HIV self-testing tool was reduced, they are going to use it. That's the way qualitative sounds. Then you can now put a quote on what that participant actually said. So for qualitative, you would not be seeing numbers. You won't be able to say so percentage of people said this, so percentage of people. So you would only be describing what they said. So that's why it's qualitative. Yeah, so but for the quantitative, yes, you can actually deal with numbers. And because you can deal with numbers, that's why you can do descriptive and inferential statistics. So I think I tried to summarize what I got from your thoughts. But if you ask a specific question, which I'm not sure, you can still unmute and ask the question directly. So persons have been posting good resources here that you can use for qualitative data analysis. Ugo also posted atlas.ti. Yeah, so you can check those out. Rima or
Hello, sir.
Nuhu. Yeah.
I got you.
I would like you to forget that. So I forget something. You are right in that you are saying according to the quantitative data for information statistics. So if I remember, I grouped so in a table For example, the teenagers who told me that they haven't lack of information in family planning methods, for example, to avoid the pregnant. So I grouped them on a table, and it becomes like quantitative data. So I remember, and when I got that, I tried now to use square to test the association between the lack of information and pregnant in outcome. So that's why. Thank you for remembering.
Okay, all right, yeah, thank you too. Yeah, so as long as it's a quantitative data, and as long as you can actually get frequency and percentages from that data, satisfactorily, yes, you can do inferential statistics. Yeah. So like for you now that you had mentioned you would be checking for differences in percentages, yes. So chi-square would be the appropriate test of significance to use in this respect. Yeah.
Yeah, good afternoon.
Yeah, good afternoon.
I have a question with regards to the qualitative data.
Okay.
Yeah, qualitative data, more or less, a form of data that are captured through expression of impression and emotions. And then I really want to know, you made mention of the fact that you cannot make a percentage with the qualitative data. I'm just thinking loud that perhaps a number of respondents, after gathering data with the questionnaire, are you still not able to say, okay, so percentage of this person responds to this question in this regard, whether yes or no or whatsoever? In a nutshell, I'm trying to say what best tools can be used to analyze qualitative data.
So the thing now is, like I mentioned earlier on, is it qualitative based on the study, or is it qualitative based on the way you wrote the question in the questionnaire? You see, we need to be clear on this. A true qualitative study, there's no questionnaire. What you have is an in-depth interview guide or a focus group discussion guide. You just have people and you ask them some questions, they answer the questions, and you're recording those questions. And after you're done with recording, you transcribe verbatim what they said. Then you move the transcript into the statistical software that have been listed here, or the qualitative analysis software that are listed here, like the Atlas, In Vivo, and the Max, and the rest of them. So what this software does, they give you recurring themes. That means the expression of people that reoccurred more, those themes, and sometimes you can call them sub-themes and main themes. So it gives you themes, all right? So the not how many times those themes appeared. That's not the focus. The focus is, was the theme there? Yes or no? Not all right. Yeah. But in the example now you're giving that you used questionnaire, that is not a qualitative study. That what you probably did was you probably have some open-ended questions in your questionnaire, meaning you didn't give them options. You just wanted them to write inside the questionnaires. Of course, as long as it's a questionnaire and it's an open-ended, yes, you can actually tell how many people said what they said. Yes, you can. So because you can quantitatively extract these things from the questionnaire, yeah, it's a quantitative, not qualitative. Now, a true qualitative does not use a questionnaire. So I don't know if I'm clear.
Yeah, it has helped a lot. But then, can you affirm on the software you mentioned?
Yeah, it's in the chat box. If you want to do qualitative, meaning you interview people, you transcribe it, and you want to get out teams, I think they had listed some in the chat. You have In Vivo, we have Atlas, we have MaxQ. They are best for qualitative, extracting themes from transcription from an interview. But if you're using a questionnaire, then you will still use the regular statistical softwares we do, like the EPINFO, SPSS, Stata, SAS, Arrow, Python, Pandas, yeah.
Oh, thank you. Thank you very much.
All right, thank you. So I think there's no other. So please take a look at the chat box. Asta, she's been posting a lot of useful links, that you can actually click to join to get regular information. She had even posted some links for upcoming events. There's an event for the 7th method and tools in qualitative data analysis. Okay. So for those of you that have been asking a lot of qualitative questions, I think this is your webinar now. You can register and jump in. All right. For those of us that speak French, like the guy from, is it Congo? Yeah. So you can join the webinar on July 18, French tea time. So I think that is it for now. So before we Asta wraps us up, I think I'm seeing Peneha Ford's hand again. Maybe you have one more question before we wrap up for the day.
Yes, I just wanted to say thank you for the insightful session. However, I wanted to find out if your organization offers funding for researchers.
That's the Rising Scholars. Not directly, but they have resources in terms of links that can point you to funders. Yeah. So I know we used to have something like that in Rising Scholar, but I don't know if Asta can lay hands on it. But there's like a page or so where potential funders were actually listed, but not directly from Rising Scholars itself. But I know that last year, last 2 years or so, Rising Scholars advertised funding for research. Yeah, they did. Yeah. So, but they are not advertised anyone recently. So I don't know if they are going to do that, but they share resource for. Asta, do you have a link to that resource? I think it was Andy that wrote that.
I am trying to search right now because we just changed our website.
Okay, so
Yeah, and things are here and there. Let me see if we can find something. But we don't do funding ourselves, but we do have a repository of potential funders.
Okay.
That and also verbally. So Asta, you can take over. Thank you. Asta, can you hear me?
Yes.
Okay. Yeah, okay.
Do you want to?
Yeah, I was saying you can take over.
Thank you so much, everybody, for asking many good questions. We loved it. I learned a lot, and I think you have learned a lot as well. There are multitude of resources from Felix himself on our website and also on our YouTube. You can go and watch the previous webinars, and your conceptual clarity will be even more, I think, because we have already discussed many things in our previous webinars. Yeah, let's take a picture before we end this. And while you turn on your video as you are comfortable, I would like to remind you of the links that I have already shared. So So you can see I have shared LinkedIn, Facebook, YouTube, website, Google group forum where the discussions are happening on regular basis. And if you sign up to our website, make an account, you get the regular updates from Rising Scholars and the mentorship, data science hub that we talked about. And if you want to write blogs like the one Felix have written, feel free to see through the submission guideline and write a blog. And many of you were surprisingly very interested on the qualitative research. It is surprising because we have a session from July 7th. I think Monday, we have a session on methods and tools in qualitative data analysis, covering data collection, sampling, validity, and QDA tool. You can register it. The link has already been shared. Then for all of you who are French speaker, I am not. We have French tea time with Rising Scholar, where we will be discussing time management skills for early career researchers. It is not as technical. It does not seem very technical as the statistical discussion we have had today, but I bet it is going to be very, very informative because it is a nuance, the skills that we need, right? And we'd also Felix mentioned time and again about atlas.ti. Actually, we are having hands-on learning session on the same on July 25. It is a workshop where we will be developing the skill of using the application Atlas for the qualitative analysis. Please feel free to copy this link and make sure that you are like participating. Okay, so the methods and tools in qualitative data analysis, it says the registration is closed. Okay, I think we are full because many people have registered because we have already shared it previously, but I'll talk with the organizer and see what we can do. So let's take a picture. Please copy all the links if you are interested and register whenever you can, okay? Okay. Yes. Anyone else wants to turn on the video? Okay, I think this is all we are gonna have. And everybody please smile. Or something like, wow, what a day it has been. Now the weekend is coming. Okay, so see you around for our other events. Thank you so much for joining in and join for more qualitative exploration in the upcoming days. And for French scholars, there are other things happening. And yes, sign up on our website to get all this information. And thank you so much, Felix. Like always, the session was very, very powerful. And we'd love to have you on upcoming days as well. Thank you so much, everybody. Bye-bye.
Bye-bye. Thank you.
Bye-bye.
Bye.
Thank you very much.